So let's read the question. AB is a line segment. So here AB is a line segment. Now P and Q are points on opposite sides of AB. This is point P, this is point Q. So P is above AB, Q is below AB. So P and Q are points on opposite sides of AB such that each of them is equidistant from the points A and B. What does the word equidistant means? Distance is same. So each of the points, that means both P and Q, each of them are equidistant from A and B. So what this means is that the distance of P from A is the same as the distance of P from B. Similarly, the distance of Q from A is the same as distance of Q from B. See, both P and Q are equidistant from A and B. So P is equidistant from A and B. That means the distance of P from A is the same as the distance of P from B. Similarly, Q is equidistant from A and B. So the distance of Q from A is the same as the distance of Q from B. So Q is equidistant from A and B, meaning QA is equal to QB, and P is equidistant from A and B, meaning PA is equal to PB. Now, show that the line PQ is the perpendicular bisector of AB. So we have to show the line PQ is the perpendicular bisector of AB. What do you mean by perpendicular bisector? Perpendicular means PQ is perpendicular to AB. So we have to show these two angles to be 90. Next, it is the bisector. That means it is going to divide AB into equal parts. So we have to show AC is equal to BC. I repeat, when will PQ be the perpendicular bisector of AB? Perpendicular means the angle between PQ and AB is like this, 90-90, perpendicular. Bisector means it is dividing AB in two equal parts. So AC and BC. So let's begin. So first, let's begin with what we have to prove. So this should be very clear. What do we have to prove? We have to first of all show that these two angles are 90 degrees. That is angle PCA and angle PCB are both equal to 90 degrees. Next, AC is equal to BC. So it's very important for you to understand what you have to prove. Perpendicular bisector means perpendicular means 90 degrees. Bisector means divide AB in two equal parts. So this is what we have to prove. So let me rub this off. So now that we've understood what we have to prove, now next step is write down what is given to us. So we are given that PA is equal to PB and QA is equal to QB. QA is equal to QB. So these are two very important things in the question. You have to understand what is given to you and what we have to prove. So now we have to prove that AC is equal to BC, right? Whenever we have to show that two corresponding sides are equal, what do? Look for two triangles which have these as their sides and show them to be congruent. So I want to show these two sides to be equal. So I can take these two triangles, right? That is triangle PAC and triangle PBC. So now in these two triangles, what do I know? This side is equal to this side. Next, this over here is a common side. So two corresponding sides are equal. Is the included angle equal? That is this angle equal to this angle? We do not know. I repeat, if I take these two triangles, triangle PAC and triangle PBC, PA is equal to PB, correct? PC is the common side. So two corresponding sides are equal. Is the included angle also equal? We do not know. So as of now, we cannot prove these two triangles to be congruent. So now what do? Look at what is given to you. This is equal to this and this is equal to this. So how do we take the help of both these things? Look at the big triangle, triangle PAQ and triangle PBQ. I repeat, focus on the big triangles, triangle PAQ and triangle PBQ. PA is equal to PB, AQ is equal to BQ, and PQ is the common side. So these two triangles are congruent. So first we'll take the big triangles. Why? Because we cannot prove these two triangles to be congruent as of now. So take the big triangle. So we'll have proof. So in triangles, first of all, triangle PAQ and triangle PBQ. What do we have? PA is equal to PB. So right over here, PA is equal to PB. Next, QA is equal to QB. QA is equal to QB. What is the reason behind this? This is given to us. So do mention over here given. Next, which side is left? PQ. PQ is the common side. So you can write over here, PQ is equal to PQ. So PQ is equal to PQ. What is the reason? Common side. So what have we just shown? In two triangles, all the three corresponding sides are equal. So whenever all three corresponding sides are equal, the two triangles are congruent. Which criteria? SSS, side criteria. So now let's smartly write the congruence statement. Choose any one of these sides. Let's say I choose this. P is equal to PB. So we'll use this. That is, therefore, triangle PA is congruent to triangle PB. Just copy this as it is. Right? Next, label 1, 2, 3, 1, 2, 3. So 1, 2, 3, 1, 2, 3. Now PA is equal to PB. Next, QA has to be equal to QB. So what is QA? I have A over here, put a Q over here. So QA should be equal to QB. QA is what? Second and third letter. This will correspond to second and third letter. So here we need a Q. So QA is equal to QB. Next, PQ should be equal to PQ. PQ first and third letter will correspond to first and third letter PQ. So all the three conditions are met. I repeat, PA is equal to PB, QA is equal to QB, PQ first and third equal to first and third PQ. So this over here is the congruence statement. What is the criteria? SSS criteria. So using the side criteria, we have shown these two triangles to be congruent. Now what is the use? The use is that once these two triangles are congruent, we can get these two angles to be equal. How do I get these two angles to be equal? See, what is this angle over here? This is angle P of this triangle. What is this angle? Angle P of this triangle. So let's check if they're equal or not. So what I'll do is, I'll continue it over here. So let me rewrite the congruence statement over here. Triangle PAQ is congruent to triangle PBQ. Now we want corresponding paths. So write down 1, 2, 3, 1, 2, 3. Now I want to check if these two angles are equal or not. So what is this angle? Angle P of this triangle, triangle PAQ. So see, P is first letter here. First letter will correspond to first letter. So what are we getting? Angle P of triangle PAQ. So angle P of triangle PAQ is equal to first letter here P. That means angle P of triangle PBQ. So angle P of triangle PBQ, this over here. So we're getting these two angles to be equal. I repeat, see, first letter corresponds to first letter. So P corresponds to P. That means angle P of triangle PAQ, angle P of triangle PAQ is equal to angle P of triangle PBQ. So now these two angles are equal. So therefore, what is this angle? Angle A, PQ is equal to this angle, angle BPQ. What is the reason? CPCT. That is corresponding paths of congruent triangles. The moment we have these two angles to be equal, now we can easily prove these two triangles to be congruent. So I'll label this as 1, right? So now we have these two angles to be equal. Now take these two triangles. So now we'll begin. That is, in triangle PAC and triangle PBC. What do we have? PA is equal to PB. So I'll write over here, PA is equal to PB. Next, these two angles are equal. So angle APC is equal to angle BPC. Next, this over here is the common side. So PC is equal to PC. Mention all the reasons. PA is equal to PB is given to us. These two angles are equal from 1. And PC is equal to PC, common side. So what is the criteria we have used over here? We have used the criteria side, angle, side. So in two triangles, if two corresponding sides are equal and the included angle is also equal, the two triangles are congruent. Hence this triangle is congruent to this triangle. So let me rub this off and then we'll continue it over here. So continuing our proof, I wrote it again. In triangle PAC and triangle PBC, PA is equal to PB. These two angles are equal and PC is the common side. So by side, angle, side criteria, the two triangles are congruent. That is side, included angle and side. So now we have to write the congruence statement. We'll take the help of this side. PA is equal to PB. So triangle PA is congruent to triangle PB, right? So what remains over here? PAC, PBC. Now use 1, 2, 3 to verify whether this is correct or not. So PA first two letters correspond to first two letters PB, check. Now these two angles are equal. That means angle P is equal to angle P. P is first letter here. This will correspond to first letter. So angle P is equal to angle P, correct. Get the side corresponding to PC. PC is first and third letter here. It will correspond to first and third letter here, that is PC. So correct. So this is the correct congruence statement. Which criteria? SAS congruence criteria. So I'll write over here SAS congruence rule. So now we have proved these two triangles to be congruent. Now what do we want? We want this angle to be 90, right? And AC is equal to BC. So let's get both the corresponding angles and the corresponding sides. So let's first get the corresponding side. I want the side corresponding to AC. So how do I get it? Search for AC in the congruent statement. AC is over here, second and third letter. So second and third letter will correspond to second and third letter. What is second and third letter here? AC corresponds to second and third letter here, that is BC. So we have got AC is equal to BC. That means PQ is the bisector of AB. It is dividing AB in two equal parts. AC is equal to BC. First thing, AC is equal to BC. Next, how do we get these two angles are 90? See, this over here is a line. So if these two angles are equal, sum is 180, each is 90. I'll explain. Let's get the corresponding angle. So this is angle C. So which is the angle corresponding to C? C is third letter. Third letter corresponds to third letter. So angle C of this triangle is equal to angle C of this triangle. What is angle C of this triangle? Angle PCA. So angle PCA is equal to angle C of this triangle, angle PCB. Why? You can see from the congruent statement. Third letter is angle C, corresponds to third letter angle C. So angle C of this triangle is equal to angle C of this triangle. So angle C of this triangle, that means this, is equal to angle C of this triangle. What is the reason for these two things? CPCT. Corresponding parts of congruent triangles. Now, as of now, we have just proved AC is equal to BC. We have not shown these two angles to be 90. So how do we show that? We know these two angles are equal, right? Now, what do we have over here? AB is a line segment. So we know whenever we have a line, two angles next to each other on a straight line, linear pair. I repeat, two angles next to each other on a straight line. They'll form a linear pair. So sum of the two angles will be 180. So angle PCA plus angle PCB is equal to 180 degrees. What is the reason? Linear pair. I repeat, two angles next to each other on a straight line. It's a linear pair. Now we know both the angles are equal. I repeat, from here we have both the angles is equal. So I can simply say 2 times angle PCA, that is angle PCA is equal to angle PCB. So angle PCA plus angle PCA, 2 times angle PCA is 180 degrees. Therefore angle PCA is 180 divided by 2, that is 90. And we know angle PCA is equal to angle PCB. So this is equal to angle PCB. So angle PCA is equal to angle PCB, that is 90 degrees. So we have proved both the things. That is, we have shown over here AC is equal to BC. Check. Next, these two angles are 90. PCA is equal to 90 is equal to PCB. Check. Hence proved. So write over here in small, hence proved. So we know the proof is over. So this is how you solve this question, right? So the key is always use what is given to you, right? So we're given AP is equal to BP and AQ is equal to BQ. So we take the help of these two corresponding sides to prove these two big triangles to be congruent. Once the two big triangles are congruent, these two angles are equal. Now the moment you get these two angles as equal, look for these two triangles, right? So in these two triangles, P is equal to PB. This is the common side, this is the included angle. So these two triangles are congruent, AC is equal to BC, and these two angles are equal. Now, both the angles form a linear pair, so each of them have to be 90, right? So this is how you solve this question. Once again, a recap. See, what is the thought process? Whenever you have to show two corresponding sides as equal, right, or two corresponding angles as equal, basically the thought process is look for triangles which have these as their parts and try to prove the triangles as congruent. So I wanted to show that AC is equal to BC. So I searched for two triangles which have AC and BC as their parts. So I took triangle PAC and triangle PCB. Now I saw PA is equal to PB, fantastic. This over here is a common side. So I got two corresponding sides as equal, but I did not know whether the included angle was same or not. That is why we could not immediately start over here. So now how do I get if these angles are equal or not? Use what is given to you. This is equal to this is equal to this. So take the bigger triangles. So we showed the bigger triangles to be congruent. From there we got these two angles to be equal. Once we have these two angles to be equal, these two triangles are congruent, side, angle, side. Once the two triangles are congruent, corresponding sides are equal. So AC is equal to BC, we got from there. Next, these two angles are equal. Now these two angles form a linear pair. So sum of these two angles is 180. Since both of them are equal, it has to be 90-90, as we have shown over here, right? So the thought process is very simple. Whenever you want to show corresponding parts as equal, basically search for triangles which have them of their parts, try to prove them to be congruent. By CPCT, you'll get your answer, right? So this is how you solve this question.